Now I hand over to Supriti Par to continue.
Thank you, Gautam sir. Now I would like to request Dr. Piyush Dotto kindly deliver his lecture. Over to Dr. Dotto.
Thank you. Am I audible?
Yes, yes.
Yeah, I am audible. Thank you very much. So let me start by sharing good news. A few minutes back, Australia matite Bharat Test series jite fitche. The fourth test, India has won by 3 wickets with 18 balls spared. So I think we'll enjoy the good news. Well, let me at the outset let me express my thanks and gratitude to the organizers, Chemistry Department, Bethune College, and Royal Society of Chemistry, Eastern India section, in general, and particularly Professor Gautam Bandyopadhyay, our Gautam Da, the HOD of Chemistry Department, Bethune College, for inviting me, and moreover for giving me the opportunity to face so many of students in the same platform. So thanks to all of you, and have a very good happy new year also. Let me try to share the screen, and you will say please that whether it is visible or not. Is it visible? How I can make it extended?
Yes, yes, yes.
On the full screen. So let me confess that I'm a bit excited because the topics that I'm going to talk on is something very, very new in the UG curriculum, chemistry curriculum. And this is the first year I think the students are going to appear in exams involving these subjects, computer applications in chemistry. Though it's the very first year, but very unfortunately we have not been able to teach them, interact with them one-to-one basis, face-to-face in the normal classes. You know why. So that is an unfortunate thing. And particularly that's why organizing this kind of session is very important. So thanks you once again, Bethune College Chemistry Department. Well, the topic is computer applications in chemistry. So you know the computer itself is a vast subject, no less vast than chemistry. So we are dealing with computer applications in chemistry. That means we are dealing with two vast subjects, and we have been given only a few minutes, so it's not at all possible to delve into either of them. Rather, I would like to have a random walk along the borderline between computer and chemistry. But one more thing, that whatever I will be saying, this is very much relevant to the students, fifth semester, particularly fifth semester students, and maybe PG first year students. Almost 100% is relevant and needed for their courses. So hopefully the students will enjoy, and you are free to interact with me whenever you need. You can unmute and ask me questions. Okay. So computer applications in chemistry. Gautam Da, how much time I am given? D level, Bethune College, Royal Society of Chemistry. Well, if you just see the human history of science, or just the history, you will see that the human intellect has gifted us so many things, right? Starting from agriculture, business, commerce, economics, technology, culture, art and music, and moreover philosophy, and of course science. So these are the gifts from our human intellect. And you know, science in the meantime has come across a long way, and it has encountered so much and so many obstacles, and a few landmarks, paradigm. Someone is sharing on the, something is written over the screen. So some paradigm shifts science has already witnessed, it has come across. And say for example, reasoning. When first humans being try to understand that what reasoning is and how they can apply reasoning, Then it was the one of the first few steps of foundation of science. And similarly, one extra thing, and that is quantification. Let me minimize it. Okay, let me bring it to somewhere else. Yeah, quantification. So it was in the preliminary days of human civilization, when they started agriculture, they're doing their exchange of things among themselves. That means business, commerce. So they needed to know that the concept of how much or how many. That means quantification. So it was needed quantification, and as a result, gradually they discovered number system, then arithmetic or algebra, and then mathematics as such and as a whole. In the other hand, science came out of some cases curiosity, and in most of the cases out of necessity. So what is science? How it works? Basically, observing the nature all around you. That is something, observation. And the basic motto of science is actually to find some, predictable and reproducible pattern in the nature, right? That is the preliminary of science. And then what it tries to do after observation, it tries to theorize, to give some model, or cast it in the form of law by means of some formula. So that is the final motto. And how do they do that? Of course, by doing experimentation. So experiment, right? Experiment gives you a lot of data. So and then you fit your data and observation into your model, and then you gradually improve your theory or model, and you go on like that. So that is how science works. Science proceeds. But as far as the quantification is concerned and science is concerned, we need something in between these two. We need a bridge, because for data handling, for data manipulation, for data storage, we need some technological support, and that is technology is acting as a bridge between this mathematical aspect that is related to quantification in one hand and science on the other hand, as such, practical science. So technology, and that technology provides you this kind of facilities, that calculation, computation, storage, retrieval, and print outs. So that means I'm pointing my finger towards that part of technology which gives you the computers, right? So computer and life taken together, it gives you ease and comfort. So it has made our life easy and comfortable, but at the same time, some discomforts are also there that I'm not going to discuss in today's day. So, but the computer, it didn't happen in one fine morning, right? It has a long evolution story, and you can identify this picture. It's a abacus. So that was the preliminary something regarding computation, and then you can identify this, the earlier preliminary stage of calculator, right? So calculator is, you can think of as the earlier version of computer. It does most of some of the things that a computer does. Of course, not all the things that computer can do. So this is earlier version, and then even today you can see in some of the shops, even in pan shops, this kind of calculators, the earlier stage of calculators. Then we went for this, what we call the scientific calculators, right? It can do a lot more than the usual ones, scientific calculator. And finally, we got this type of calculators, or you can say even the computers to some extent, and we call it programmable calculators, right? Programmable calculators. And then we jumped into what we call today really a computer. But again, you see, this is one of the example picture of earlier days computer, and a single computer was so big in size that it occupied almost the whole space of a big room. So that is the a single computer's example in the very earlier days. And then gradually it evolved by technological development. We got this kind of computers, we call it desktop computers. But even then, it has become obsolete almost, and we are handling now laptop, right? And of course, this right hand side, the very popular item of students, everyone I think, and that is the mobile, smart mobile. And as you know, even in fifth semester classes, students are doing their Fortran classes using their mobiles, those who don't have the laptops. So I am keeping side by side the laptop and the mobile. So let me have a quick glance of how computer actually works. So you know, this is a computer, and it needs lot of information and the formula or theory that you want to actually execute on. So of course it needs some information, right, as input. We call it input in terms of variable, parameter, etc., along with the formula that you need to translate. Actually, you want your computer to translate your formula, and that's why we need some formula translation. That actually it does. And the most interesting point of a computer is that it can do without being tired or bored. It can do the repetitive, accurate calculation very fast. So that's why you need a computer, and finally it gives you the results or output. And what we are talking about in this session is Fortran. So it comes from, you know, the basic job of a computer. Formula translation gives you the Fortran or Fortran. It's a name of a language. What kind of language? It was the first widely used scientific language, and still we use this Fortran, though we have so number of languages. Fortran is the first widely used, and still we use in our scientific purpose this language. That's why Fortran is in our course, in PG level courses in chemistry and as well as in physics in some cases. So it was first developed by IBM 1957 for scientific applications, and then we have got a number of versions, slightly modified over the last one. So Fortran 1966, that is Fortran 66. Then we got Fortran 77, 90, 95, 2003, and so on. But it is enough to get ideas about Fortran 77 and to some extent Fortran 90 for our purpose. Okay. So have a quick glance that the different components of a computer. Of course, you don't need to be an expert of the hardware and different components, hardware components of a computer, but on the periphery, these are the things as a component. There is an input unit, okay, and there is an arithmetic unit, and memory unit, and then control unit. They are actually interconnected. The memory unit, the control unit, and the arithmetic unit. The arithmetic calculations are being done here, and the storage part is here, and overall controlling is done by this part. And finally, it connects to a output unit. As you know that this three part, memory unit, control unit, and arithmetic unit, are taken together are called the central processing unit, or CPU, a very popular word in the computer world, CPU. And as a user, particularly as a chemist, where you stand, what do you stand with reference to the computer structure? So at the lowest level or the deepest fundamental level, it's hardware. You don't need not know much about this. And then system software. System software, that means when you boot, you start the computer, it takes a few seconds because in that time it actually runs a few programs. The operating system we call, say for example, Windows is an operating system, DOS is an operating system, Unix is an operating system. So these are system software example. And then comes the application software. For example, the PowerPoint presentation, that exactly what I am doing now. Or you can write some letter in Word, MS Word. These are the application software provided by the company, or sometimes you can write on your own, and you can download actually most of them from the internet. And here you are. So the most difficult part is hardware, and you are here, but you don't worry, because two extra levels are there that screens you, the user, from the complicated hardware part. And as a user, actually, what my role would be to write something in convenient language, we call it high level language. High in the sense that it is far away from the complicated hardware portion. The computer doesn't understand that high level language, but you understand. So something would be there in between your language, your program that you write in your high level language, and between the hardware, something would be there that I'll talk later on. And high level language example is exactly what we are discussing now, Fortran or C or C++ or Python, etc. Now, we are chemistry student, right? So for a chemist, how does a computer or a Fortran language play its role? Why really it's needed, and how really we can apply this? So let me give you a sketch that how really you can use. Suppose you have a problem, physical problem in the sense that is taken from your physical world, maybe chemistry, maybe physics, or even maybe biology or economics, whatever it is, you have a problem. Now what we do, we try to develop some model, mathematical model, and thus we convert the physical problem into a mathematical problem. Of course, it is not easy. It is something, a complicated mathematical problem. So now what we need is to make it simplified. So we need to simplify the mathematical problem by using something what we call numerical analysis, which is also in our syllabus. Host, would you please? So we start from a physical problem, then we get by means of a model a mathematical problem, which is a bit complex and complicated. Then we can simplify further by using numerical analysis that I will discuss to get a programmable problem. Now you are ready to write a program with this problem, and for writing a program, you can simplify it further by splitting the whole thing in a few steps, logical steps, and the sequence of logical steps when you write that, we call it a flow chart or algorithm. And then after getting the algorithm, you use your high level language, say Fortran for example, and then you can really write the program. So here you have got the program, and then what we do, we just put it into the computer, and a computer compiles it and then it runs it. Compile, I will explain in a while, and then it run it, and we get some results or output. And then with our physical intuition and knowledge, we analyze the results. If needed, we can go back to modify further your model, to incorporate some more concepts into your model, and then again run the same cycle. So that is how really we do work as a computer user, right? So I was telling about compilation. What you write in your high level language like Fortran or C or Python, it is called the source code, say in Fortran. So that is you are writing, but the computer hardware where it really works, it doesn't understand that, and that understand the machine language. It's something different, a very difficult one. So something you need in between your program which you understand, it is almost like English, so we call it sometimes English like language, and the machine language, and compiler is that something. So it is provided by the company, right? You can download, free download, you can get the compiler, but it itself is actually a program that compiles or translates the source code written in Fortran into something in machine language, and then only you can run that program, right? So that is how it works. And as far as our syllabus is concerned, in 5th semester in Calcutta University, to some extent more or less the same picture in all other universities, but I am focusing on Calcutta University. The components that are quite new in our 5th semester courses is number one, the Fortran itself, the language. You have to learn the language. Then as I was saying that you need the help of numerical analysis. So to some extent it is there. And then another spreadsheet or Excel, MS Excel application is there. A lot of applications of spreadsheet and Excel are there. But to me, the most attractive part of Excel is its graphical aspect, that it's so flexible to present convenient graphs that you get from your experiments, right? Physical chemistry, particularly physical chemistry experiments. So that's why we need and a statistical tool. Of course, because your data are huge in number, so you need a statistical aspect. And for all these four, we have both theory classes and experiments. So in true sense, you will be doing lab experiments with computers, but altogether it's a very different kind of lab. You don't need any wet something, bheja kichu darkar nahi. No bullet, no pipette, no anything. Only you, your brain, your heart, and a computer, and of course a teacher. Well, before I delve into the depth, let me just come across a few very popular words that everyone knows. Actually, even the students, they know it but better. Often we see that 2 GB RAM, 500 GB memory. So this kind of thing. You know, RAM, random access memory, read-only memory, these are the abbreviated forms. But my point is that regarding the capacity of a computer, often we call that, okay, this is a 64 KB 16-bit machine. Now they understand, the computer people, they understand. But as a chemist, let me try to explain a little bit. 64 KB means kilobyte and 16-bit memory. Actually, bit and bytes, they are the units of memory or storage capacity of computer. Bit is the fundamental one. How? Byte is like a word. Byte is also a unit, but word. And bit is like the letters used in that word. Okay, or you can say that byte is a highway and the bits are the lanes of that highway. So more the lanes the highway has, the more faster the road would be, right? So it's like that. So 64 KB. Now byte and bit is okay, they are the units. But what about K? K means kilo, kg, not kg, kilo. Kg means kilogram. So what do we mean by kg? 1 kilograms. That means 1000 grams. But interestingly, 1 kilobyte, unlike 1 kg, 1 kilobyte is not 1000 byte. It is 1024 byte. So 1 kilobyte is not 10 to the power 3 or 1000 byte, but it is actually 2 to the power 10 byte. And that actually equivalents to 1024 bytes. So that is a curious point, that why kilo is not defined in terms of 10 to the power 3, rather a peculiar 2 to the power 10. Okay, I'm coming to the point. And similarly, 1 megabyte is not 10 to the power 6 byte, but rather it is again 2 to the power something and 2 to the power 10, 20. And similarly, 1 gigabyte is not 10 to the power 9, but it is 2 to the power 30. So all are coming in power of 2, 10, 20, 30. So the question is, why 1 kilo is not 1000 but 2 to the power 10? I think the answer is known to you, but still, let me place a puzzle for you. What do you see on the screen as a puzzle? Anyone can unmute and please interact with me. What do you see? Any one of you? Any teacher?
No, sir. I can't understand.
Yeah, that what do you read? Just read it loudly.
Okay, 31st October is equals to 25th December, 25 December. It may be October can be in month, number month.
Okay, so you have read it out, and it gives the sense that somehow they are equating to different dates up to different months, right? October and December. But you can hardly find any similarity between the 25th December and 31st October. There is no common thing between these two.
Binary, then we are getting the same results.
Binary. No, binary is not into the picture, but you are on the right track. Who is it? Is
It is Srijukta from our our department.
Okay. Thank you very much. Actually, you are on the right track. 25 in our usual system, it is 2 into 10 plus 5 into 1. We আমরা বাংলায় বলি না এককের ঘর দশকের ঘর. So that's 10 to the power 0 is 1 and 10 to the power 1 is 10. And similarly শতকের ঘরে 10 to the power 2 and so on. So that is the usual number system we are used to, and that is one of the many, just example, one of the many. There are many number systems. This is a decimal number system. Similarly, as we are using 10 to the power 0, 10 to the power 1, so if I use something else, say for example 8, then 8 to the power 0 and 8 to the power 1. That means 8 to the power 0 is 1, So 1 into 1 and 3 is here. So 3 into 8 and that gives you 25. So actually they are equal because both are 25. But one is in decimal number system and the other is in octal number system because we are using 8. We call it the base. So in the basis. So decimal by default the basis is 10 and the digits are the digits used in this system are 10 in number 0 through 9. In octal they are 0 through 7, that means 8. Similarly you can think of any other number system. But why I am all on a sudden referring to such a number system problem? Because this is important for computer hardware. Computer actually works in binary number system. So like octal, like decimal, binary is another system where the number of digits is again 2 and they are just 0 and 1. So at the fundamental level, what computer understands any number in terms of 0 and 1. So that's altogether a separate story, that how we can represent a number in decimal binary way and the reverse. We are not discussing that. But the question remains that why binary is so important in computer. So I'm leaving it as a task for student to answer this question. Okay. Now let me enter the world of Fortran. It's a language. So it needs some alphabets, Bornomala, Awa, Kokho. And in Fortran, the Bornomala consists of digits, 10 digits, 0 through 9, and then all the 26 alphabets, A through Z, and then some special symbols. These are the plus, minus, star, slash, dot, comma, inverted comma, equal to, dollar, etc. These are the symbols. You can find many other things on the keyboard, but all are not necessarily valid character. I can call it character, valid character in Fortran. This is the list of the valid character. And one more thing, that you can write the program either in capital letter or in small letter, is no problem. The language is not case sensitive. Okay. Then GT for greater than, LE for less than equal to, GE for greater than equal to, and NE is not equal to. So these are the logical operators we will come across later on. One more important thing I will try to mention, one of the basic strength of any programming language, including Fortran, this kind of statement, n equals to n plus 2. So in simple maths, it is absurd, something nonsense. N equals to n plus 2, that means n cancel out. So n equals to n plus 2, it is absurd, meaningless in our usual sense, because on both sides n cancel out, and that means it gives 2 equals to 0, which is absurd. Here in Fortran, most often we will use this kind of statement or expression. Here equal to sign is not really meaning any equality. Rather, it is, we call an assignment statement. It actually does two actions. First of all, on the right, it adds 2 to the current value of n, and then it gets a value which is not the previous n value, and it stores in the same name or location or address of n. So it is reassigning the n name variable by adding 2 to the previous value or current value of n. So that is why you can use this statement as a valid statement. It is not unlike the usual mathematical statement. Well, if you really try to go into the Fortran study systematically, then you have to go through at the very beginning constants, variables, arithmetic operators, expressions, arithmetic statements, and logic. But in today's this limited time, I don't have any opportunity to discuss depth of any of the concepts, but I will touch this important aspect, logic. So you know that you have to have this faculty, or you can develop it, of course, the logical faculty for writing an efficient program. So I will give just or demonstrate just one or two examples. Say, for example, the problem is that you have been given two values, A and B, variables A and B, like A is 2.5 and B is 3.5. And what you want, that find the values of A and B as a result of. If I write a program like this, just two statements, A equals to B, B equals to A. So what would be the result? It looks like that, okay, A equal to B and B equal to A. That means A takes up the value of B and B takes up the value of A. That means actually you are exchanging the values of A and B, isn't it? It apparently it looks like that. Okay, let us check. Is it so? No. Wrong. In the first statement is okay. A is B. So B, the current value of B is 3.5. So it is assigned to A. So now A is 3.5, but initially it was 2.5, and that value is erased from its memory because you have redefined A by this statement. So A is now 3.5. Now you are writing B is A. So on your left B, on your right A, but A is already redefined to be 3.5. So now this 3.5 value is assigned to B. So what you see as a result, that both A and B are 3.5, 3.5. So that just a simple demonstration that how you have to think logically, involving the grammar of Fortran also. So the answer is A and B both are 3.5. But what you really need, that exchange, if you really need the exchange of A and B, that is 2.5 and 3.5 are exchanged, then you have to write slightly differently. How? Again, you have to be logical. What you do, here the problem was that the value A 2.5 was erased. That's why the problem. So what you do, before it gets erased in the second statement, I store the value of this A, that's 2.5, in a temporary separate location or variable name called T. So I am storing in the beginning that T is A. So that value 2.5 is stored in T. Now I can write A equal to B. So A takes the value of B, that is 3.5. Fine, A is now 3.5. But now B, you want it to be 2.5. But that 2.5 value is stored in T. So you just write B equals to T. So one more line is added compared to this, and that is T equals to A. Now the result would be, you see, as I have told, that T takes the value 2.5, A takes the value 3.5, and B gets it back from T to be 2.5. So what you really want, that A to be 3.5 and B to be 2.5. So that is a simple example of how one can play with the logic. But of course you need a systematic study of the language itself. And for that, I would refer, okay, before that, I am giving an exercise for my students, that there are three variables and you have to exchange the variables in this fashion, that A takes up the value B, B takes up the value of C, and C takes up the value of A. Okay. And for the systematic learning of the language itself, along with this logical part, you have to follow. You can follow anything, but my suggestion is that you can follow a YouTube channel. In that channel, there are a few videos explaining from the beginning, explaining step by step the learning of fun with logic in learning Fortran. And this is a video, YouTube channel of myself. And a few playlists are there. Just for your curiosity, this is the playlist where a number of videos are there. Fun with logic in learning Fortran. And another series is there, PCTF series on Fortran, that is Physical Chemistry Teachers Forum series on Fortran. For your information, since last 8 years, there has been a very successfully running forum, Physical Chemistry Teachers Forum, and their objective is to just exchange their experience, views, and try to enrich each other so that they can contribute more to the community of students. So it is the 8th year, and this is the ongoing series. In fact, today at 7:30 we have a series lecture on Excel, that is part of our syllabus as well. So in our PCTF series, actually what we do, we try to cover the latest inclusion, newer inclusion in our syllabus. But unfortunately, we can't accommodate the students in that seminar. So let me switch over to something deeper, a real program or logical program. The thing is that problem, okay, we have been given a problem, and then we need some logic to frame the algorithm, and then we can write a program. So let me explore with a demonstration of a very simple program, jod bijod. So a number is given to you, I mean the computer, and it's tasked to observe or find whether the number is odd or even. Okay. So or a number whether it's divisible by some other number, etc. For human being, it's a very simple job. Within fraction of second, any child can say that whether 7 is odd and 8 is even. Fine. But for a computer, even some simple tasks becomes very tedious. You have to understand. Well, someone is trying to write on the screen something. To the simple problem of program jod bijod, let me see that what about division. A by B is C. Mathematically, you can cross multiply BC to get A, right? Irrespective of C being an integer or not. So it doesn't matter whether C is an integer or not. B and C cross multiplied always gives you back A. Say for example, 8 by 2 is 4. So 2 into 4 is 8. Or 7 by 2 is 3.5. So 2 into 3.5 is 7. So you are getting back the original number in both the cases. Here 8 and here 7. So one is odd and one is even, but it cannot distinguish because in both the cases you are getting the result. You are getting back. So by this you cannot distinguish the odd and even by this procedure. But please hold your tongue and let me love integer division. But in Fortran, we have something very special called integer division, and probably by using the concept, I can easily write an algorithm or program to say whether a given number is odd or even. And as I mentioned, that integer, a computer does the integer division separately in a separate fashion than from that of the real number division. I am explaining. 8 by 2 is 4, so 2 into 4 is 8. As if m by n equal to k, so cross multiplication n into k is m. Okay, but that is true. That means you get back the same m if k is an integer. Like this example, here k, that is 4, is an integer. So you are getting 2 into 4, 8, the same original number given. But now follow what happens. 7 by 2 is 3.5. But since you are doing an integer mode division, then 3.5 is not an integer. So it will truncate automatically to 3. The result would be 3 because you are using the integer mode division. How you are using that is a separate story, but you just follow the logic. Then if you cross multiply 2 into 3, that gives you 6 but not 7. So the original number 7 is not coming back as a result of this cross multiplication because this time the quotient is not integer. So now probably you can use this argument to differentiate a number whether it's odd or even. So the logic is like this, that m by n is k যদি ভাগফল k ভাগফল কোশেন্ট পূর্ণ সংখ্যা হয় তাহলে ক্রস মাল্টিপ্লিকেশন k ইনটু n আপনাকে ফেরত দেবে সেই আগের m টা, রাইট, পুরনো m। কিন্তু যদি ভাগফল পূর্ণ সংখ্যা না হয় তাহলে দেবে না। তাহলে k into n, so in language, in Fortran term, we write k star n, multiplication sign is star, and then I was talking about the logical operator eq means equal and m. So it tells that if যদি k star n, k এর সঙ্গে n এর গুণ, এই গুণফলটা যদি equal to m হয় তাহলে পূর্ণ সংখ্যা হলো, তার মানে ইন্টিজার হলো, তাহলে হবে। অর্থাৎ algorithm on the basis of this argument of logic, then how we can go ahead. So what we see, যে 2 দিয়ে ভাগ করলে মেলে কিনা, আমরা তো এইভাবে জোড় বিজোড় দেখি যে whether it is divisible by 2, or if you ask that whether a number is divisible by any other number, say n, then we ask whether n দিয়ে ভাগ করলে মেলে কিনা, এই তো দেখি। এটা অন্যভাবে দেখা যায়, আমি যদি বলি যে 2 দিয়ে ভাগ করলে ভাগশেষ যদি 0 হয় তাহলে 2 দিয়ে ভাগ করলে মিলেছে, তার মানে জোড়, even number, or in other words you can say that whether the remainder is 0 or 1. আবার অন্যভাবে ভাবতে পারি যে ভাগফল যদি পূর্ণ সংখ্যা হয় তাহলে আমরা বলতে পারি যে মিলেছে, অর্থাৎ জোড়, রাইট। তাহলে কোসেন্ট ভাগফল whether it is integer or floating value, এইটা আমরা যদি দেখি তাহলেও আমরা বলতে পারি। So there are three possible arguments and I will be using the last one, যে যদি ভাগফল পূর্ণ সংখ্যা হয়। এখন ভাগফল পূর্ণ সংখ্যা হয় তার আর্গুমেন্টটা তো আমরা অলরেডি দেখে নিয়েছি। আমরা সিম্পলি এটা দেখব যে k star n equal to m, এটাই দেখব। যদি yes হয়, if yes then একরকম, if no আরেক রকম। So we have already learned that ভাগফল যদি পূর্ণ সংখ্যা হয় এটা কি করে দেখতে হয়। ওকে, এটা আমরা জানি, ধরে নিয়ে যদি আমরা এগোই তাহলে আমার অ্যালগরিদম বা যুক্তি প্রবাহটা কিরকম দাঁড়াবে। Okay, one thing, I was speaking in English initially, but later on I switched over to Bengali. যে আমাকে একটা নাম্বার দেয়া হলো, মানে কম্পিউটারকে, আমি এখন কম্পিউটার ধরে নিচ্ছি, তাহলে যদি নাম্বারটা ভাগফল পূর্ণ সংখ্যা হয়, মানে আমি 2 দিয়ে ভাগ করব, তাই তো, জোড় বিজোড় দেখার জন্য। আর যদি ডিভিসিবিলিটি বাই নাম্বার দেখি তাহলে n দিয়ে ভাগ করব, হোয়াট এভার ইট ইজ। আমি সেই ভাগফলটা যদি পূর্ণ সংখ্যা হয় তাহলে আমি বলছি যে তাহলে সোজা 30-এ যাও। 30 মানে 30 একটা নাম্বার, অ্যাড্রেস নাম্বার, লেভেল নাম্বার, উই কল লেভেল নাম্বার। তো যদি হয়, মানে এই যদিটার উত্তর যদি হ্যাঁ হয় তাহলে ও লিখবে লেখো জোড় বা বিভাজ্য। ফাইন, সেটা আমরা চাইছি। এখন যদি এই উত্তরটা না হয়, যে ভাগফল পূর্ণ সংখ্যা নয়, তাহলে তো 30-এ যাবে না, তাহলে নিচের লাইনে চলে আসবে। নিচের লাইনে এসে লিখবে লেখো বিজোড় বা বিভাজ্য নয়। ফাইন, সেটা আমি চাইছিলাম যে হয় ইয়েস অর নো, হয়ে গেল। এবার মুশকিলটা হচ্ছে যে কম্পিউটার সাধারণত উপর থেকে নিচে নামে। এখন যদি এই যদির উত্তরটা না হয় তাহলে নিচের লাইনে এসে লিখলো যে ভাই এটা বিজোড়, তারপরে কি করবে? তারপরে এই লাইনে চলে যাবে, যদি মাঝের লাইনটা বাদ দিই তাহলে আবার 30-এ আসবে, কোনো আবার লিখবে জোড়, তার মানে একসঙ্গে ও বিজোড়ও লিখছে জোড়ও লিখছে। দ্যাট ইজ অ্যাবসার্ড, দ্যাট ইউ ডোন্ট ওয়ান্ট। তাহলে আমি কি করব? উপর থেকে নিচে নামবো, যদি উত্তরটা না হয় তাহলে ও লিখলো বিজোড়, তারপর আমি লিখলাম যে তুমি ওই 30-এর লেখাটাকে বাবা অ্যাভয়েড করো, ইউ অ্যাভয়েড দ্য লাইন, জোড় লেখাটিকে এড়িয়ে যাও। সো এইরকম একটা আর্গুমেন্ট আমি যদি দিতে পারি তাহলে ও পরের লাইনে গিয়ে যা লেখা থাকবে থমকে যাও, দাঁড়িয়ে যাও, খেলা শেষ, এরকম একটা আর্গুমেন্ট আমি দিচ্ছি, যেটাকে আমরা ইন ল্যাঙ্গুয়েজ টার্ম বলছি কন্ডিশনাল স্কিপ। অর্থাৎ আমি এই যে সোজা যাও বলছি, অনেকগুলো লাইন পেরিয়ে সোজা বেরিয়ে ওখানে যাও, তার মানে আই ওয়ান্ট টু স্কিপ conditionally, subject to some condition written over here, and here জোড় লেখাটিকে এড়িয়ে যাও মানে unconditional skip. So this is the logical flow or algorithm, but now my task is to convert it into a program using the programming language, grammar. But what I'm trying to show you that actually this is nothing হাতির কি জানো বলো না, হাতি ঘোড়া হাতি এরকম কিছু নয়। আমরা বাংলায় যেভাবে ভাবছি লজিকটাকে, ঠিক সেটাকেই আমরা প্রোগ্রামে নিয়ে যাওয়ার চেষ্টা করছি, just using a slightly different language, that is Fortran. So let us see how we can really think in Bengali or in a vernacular, and then you can translate. দেখা যাক, বাঁ দিকে আমি আমার আর্গুমেন্টটা লিখেছি ফ্লো চার্টটাকে, আর ডান দিকে আমি সেটাকে প্রোগ্রামিং ফর্মে লিখছি। যদি ভাগফল পূর্ণ সংখ্যা তাহলে 30-এ যাও, একদম ইংরেজিতে ট্রান্সলেট করছি জানো। If quotient is integer then go to 30, exactly as if I am translating. তাহলে লেখো বিজোড় বা বিভাজ্য নয়, write star comma star, this is the syntax of Fortran language, odd or not divisible. এবার আমি লিখছি জোড় লেখাটিকে এড়িয়ে যাও, so go to 40, just skip, go to 40 মানে এখানে চলে আসবে, অর্থাৎ 30-এর লাইনটাকে স্কিপ করবে। আর যদি 30-এ আসতো, এখান থেকে সরাসরি 30-এ আসতো, তাহলে ও পরের লাইনে আবার 40-এ এখানে আসতো, so pause, stop, end. So in both the cases, either whether it's odd or even, I am getting a correct statement, right? So that is how we can translate the algorithm into program. Finally, this is the complete program. Exactly, I am writing it again, and but now the question, এইটাকে কি আরেকটু, এটা মনে হচ্ছে না আমরা বাংলায় কথা বলছি কিন্তু আসলে ফোরট্রান বলছি, মানে কবিতার মতো মনে হচ্ছে আমার কাছে। তো যে আমি কবিতার মতো বাংলায় না বলে ফোরট্রানে কবিতা লিখছি। তো তা যদি হয় তাহলে আমার নেক্সট প্রশ্ন, যে আমি এই কবিতাটাকে আরেকটু কাব্যিক, মানে রবীন্দ্রনাথ থেকে জীবনানন্দে যেতে পারি কি? আর একটু কাব্যিক করতে পারি কি, অর্থাৎ my question in other words is that whether I can make use of even more stronger some syntax of Fortran. So let us see how we can make it even more stronger. আর একটু কাব্যিক, সেটা হচ্ছে খুব সিম্পল। এটা হচ্ছে ওই কন্ডিশনাল স্কিপ, আনকন্ডিশনাল স্কিপ, এইটাকে আমরা কিভাবে ম্যানেজ করছি দেখুন। আমি বাংলাটা আগে বলছি যে এম আর এন দাও, এখানে আমি আমার প্রবলেমটা হচ্ছে যে আমি এম whether it is divisible by n এটা দেখতে চাইছি, রাইট? m whether it is divisible by n or not। তাহলে আমি লিখছি কম্পিউটারকে এম এন দাও, এই যে উইদিন কোট সাইন লিখছি, মানে কম্পিউটার এটাকে স্ক্রিনে ভাসিয়ে দেবে। কম্পিউটার আমাকে দেখাবে যে তুমি এম এন দাও। এবার আমি কিবোর্ড থেকে দিলাম, তাহলে ও এম এন পড়লো। পড়ে এবার ও কি করবে, এম কে এন দিয়ে ভাগ করলো। ভাগ করে যদি ভাগফল পূর্ণ সংখ্যা হয় তাহলে ও লিখলো লেখো জোড় বা বিভাজ্য। আর যদি না হয় তাহলে অটোমেটিক্যালি ও এই পার্টটা বাদ দিয়ে অটোমেটিক্যালি আমাকে আর ওই আনকন্ডিশনাল গো টু দিতেই হচ্ছে না, মানে আমি আরো কাব্যিক হয়ে গেছি। আমি বলছি যে যদি হ্যাঁ হয় উত্তর তাহলে এটা লেখো, যদি না হয় তাহলে এটা লেখো। যদি শেষ, যদির খেলা শেষ, একটু দাঁড়িয়ে যাও, খেলা শেষ। সো নাও লেট আস ট্রান্সলেট। রাইট গিভ এম এন উইদিন কোড, তার মানে এটা স্ক্রিনে ভেসে উঠবে, আমি যখন রান করব প্রোগ্রামটা স্ক্রিনে এটা ভেসে উঠবে। রিড এম এন আমি যেই কিবোর্ড থেকে দেবো ও রিড করার জন্য পড়ে নিল, রিড থাকার জন্য। এবার আমি বলছি কি যে ভাগফল যদি পূর্ণ সংখ্যা হয়, সেটা তো আমরা অলরেডি দেখেছি যে এম বাই এন স্টার এন ইকিউ এম, দেন ইট কামস হিয়ার ইফ দ্য আনসার ইজ ইয়েস। তার মানে এম যদি এন দিয়ে ডিভিসিবল হয় তাহলে উইল গেট ব্যাক দ্য সেম এম and it will come in the then block, and if it is no then it will come in the else block and then end it। অর্থাৎ আমরা বাংলায় যেমন বলি না যে যদি ভাই এটা হয় তাহলে ভাই ওটা, আর না হলে ভাই সেটা। So exactly we are doing the same thing by using English like language, if then something else something else and then over, end it। So this is the syntax of this program. So if you are interested, if I run the program, this final program is okay.
Yes, it's fine now.
Yeah, it's fine.
Yes.
Thank you. So this is then I will I'm going to share screen.
Yeah, share screen. That's it. The whole screen. Yes,
Share.
it's
Do you
come
see
now. Yes.
It's coming.
Yes.
Okay. So let me the program. Do you see the program on the screen?
সেই প্রোগ্রামটা দেখা যাচ্ছে,
দেখা যাচ্ছে, ওকে।
রান হচ্ছে
না, এবার আমি রানে যাচ্ছি। ওকে, এবার রানে যাচ্ছি। এবার দেখে বলো তো যে কিছু আসছে কিনা। হোয়াট ডু ইউ সি?
ইটস রানিং, দেয়ার ইজ রানিং
and give m and n
ODD underscore even,
and then in
underscore even, and the status is running.
বারোটা কুড়ি থেকে শুরু করেছি। Okay, so now I was talking about numerical analysis. Actually all these things are just taken from part syllabus, so just to give you a flavor of because I don't have any intention to discuss all these things in details, it's not possible either. So numerical analysis and programming, and this together, how it gives you the theoretical aspect, that is Newton, that is the numerical analysis part, and the programming, that is the experimental part. So these are like this. First of all, Newton-Raphson method is just a method for finding roots of an equation. Very often we need solving some equations in physics and chemistry in other branches, and similarly we need some numerical differentiation, numerical integration, and some plotting, least squares method. That means very often in physics and chemistry we need to draw a best fit line, a straight line, and then we rely on our eyes only. But here a computer provides you a very scientific best straight line that you can draw through a scattered set of points, and that we call least squares method. So the logic behind all this analysis that you have to learn in our theory classes, and these are the programs that are actually the syllabus. So I'm not going into reading, wasting my time just reading it out. Only I'll try to give one such flavor that how a chemical problem can be a mathematical problem, and then using numerical analysis, algorithm, program, etc., you can get the result that you want. There are from syllabus there are a few more. So for one example, I will discuss only that determination of pH of a weak acid. This now sense very much of chemistry. So weak acid HA is dissociates as H plus and A minus with initial concentration C, and suppose degree of dissociation is X. So as you know, a class 11 student knows that this are the picture, and then you can, since it's an equilibrium, you can express the equilibrium constant in terms of the product of concentrations of H and A and divided by the undissociated HA. So if you replace that HA etc. by this term Cx and C1 minus X, finally you will get what you get is a quadratic equation to find X. So you need, what you need is the X, the degree of dissociation, and if you know the X value, then you can get the HA. Because the HA concentration is C into 1 minus X, you can get the H plus or A minus, whatever you want, Cx. So C is known to you, initial concentration, and X what you exactly want to know from your problem. And it is theoretically and your chemistry knowledge gives you a quadratic equation. So now, as I told, that chemical problem becomes a mathematical problem. So now it's a mathematical problem. Now you can handle it analytically. But since you are using some programming language or computer, you can solve this equation by using a program to get X. By using that, what I was calling a Newton-Raphson method as the part of numerical analysis. So once you get X by your program, you can evaluate C into X, and then you take log and you get the pH. So this is just a simple demonstration that what really we do in physical chemistry experiments. Right, and there are a number of such experiments. I think it is 7 or 8 experiments that we have to do in our experiment course using Fortran, and there is parallelly one more part regarding Excel. So these are the few examples that I am not discussing in details. A best fit that I was talking about, a very famous kinetic equation that also is solved by and again, I would like to refer these two books. Gautam Da knows it very well, that whatever the experiments are there in your syllabus, in Fortran or Excel, they are covered, 100% covered as per syllabus in these two books. These books were actually published as a result of the two workshops conducted by Bankim Sardar College and PCTF that I was talking about, Physical Chemistry Teachers Forum. So they are available. Initially they were out of print, but Amazon even, or Sarod Book House, or if you don't even get in from Amazon or Sarod Book House, you can contact Bankim Sardar College or me, Tiotos Datto. If you are interested, you can collect these books. That would provide you the whole lot of thing that it does a lot. But I will just a few minutes. Do I have a few minutes more? Because Gautam Da told me. Yeah. Sure. So instead of going into the depth of the different types of use of spreadsheet Excel, I would like to give an overview of something different, and finally using a demonstrative example of Excel. And that different something is that Sate Samudra, Chaya Ritu Sate Samudra, and how the 7 rivers are connected. You know, connectedness gives you the beauty. So interconnectedness is really the beauty. So I'm explaining something very beautiful, as I claim. And what are those 7 rivers that they are merging into the ocean? One is arrangement, a concept of mathematics. Combination, they are all mathematical concepts. Combination, and then binomial expansion, a plus b whole to the power n, and then gambling, tossing the coins. And then random errors. The analytical chemists are very much interested in random errors. And then NMR spectra, again organic chemists are very much interested. And some finally probability. So there are these 7 rivers, all are in the same ocean we call Pascal triangle. So let me quickly give you some of the ideas that say just childish game a plus b whole to the power square or cube or 4. You know the formula like this. So a plus b is a and b, a plus b whole square is a square plus 2ab plus b square, and so on. But if you just pick up the numbers associated with these terms, then you can have a picture like this: 1, then 1a and 1b, 1 1, then 1a, 2ab and 1b square, so 1 2 1. Similarly 1 3 3 1, 1 3 3 1. So what are here? Actually, they are coming from this expression a plus b whole to the power 4. So you may not remember a plus b whole to the power 4 or 5 or 6, the formula, but by this thumb rule, you can very easily construct the whole set of numbers by simply from using from this triangle. And as you know, this triangle is very famous Pascal triangle. And how we generate it? Just you see, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, and so on. So if you go on for the last line, 1 plus 3 should be 4, 3 plus 3 should be 6, and 3 plus 1 should be 4. So you get 1 4 6 4 1. Actually, these are the numbers for this formula a plus b whole to the power 4. So you see how it connects a completely separate aspect of mathematics with a very simple thumb rule, Pascal triangle. So it is associated with arrangement, because a square b 3. Why 3? Because a square b, how you can arrange? You have been given 3 compartments, example, and how you can arrange a square b, that means 2 a's and 1 b. You can do it in 3 ways only. So that's why the 3 is coming here. Similarly for 3ab square, and similarly for other terms as well of the whole triangle. So this problem is associated with something we call arrangement. And that is, you know, that's a combination formula, that how many ways you can arrange R objects taking from n given objects. This is the factorial formula. So that again gives you the same set of numbers, but it's a completely different aspect of mathematics, right? It is connected. How? And this is, you know, the expansion coefficient, binomial expansion. So a plus b whole to the power n. What is the general formula? If you ask class 6 7 student, they will tell about this this thing. So but this is nothing but NCR they are using, and that NCR is nothing but this formula, and this is nothing but the arrangement, and that is nothing but this Pascal triangle. So you know how beautifully they are interconnected. And similarly, if you just go on gambling 4 coins, then what are the possibilities? Either all 4 are heads, all 4 are tails. Similarly, 3 head and 1 tail, 2 head and 2 tail, and so on. So a total of 5 options would be there. Now, if you say head is 1 and tail is -1, then those 5 possibilities would give you the total value either +4 or -4, maximum minimum, and the other values are -2, 0 or 2, depending on how many heads and how many tails are there. Now the question is, if you do the toss 4 coins together, then you can get any one of these results, right? Any one of these. But the question is, if you do it a number of times, say 16 times, 100 times, then out of this 5 possibility, is there any maximum or dominating possibility? If you know beforehand by using mathematical knowledge, then you are a very good, excellent gambler, right? A great gambler, Amitabh Bachchan. So, but you have to, for that you have to know the statistics, probability. And we can answer this question that yes, out of these 5 possibility, the most likely possibility is 2 head and 2 tail, and that means 2 plus and 2 minus, that is 0. So if you want to bet out of this 5, as a mathematician, you should bet on 0. And maybe you will lose the first time, second time, third time, but at the end of the day, you will be the gainer. And that same thing exactly happens in our random error distribution. That is, suppose you have some errors in your experiment which you cannot control, that is the quite random, and suppose the value, for convenience, suppose the values are just plus minus 1. So same thing like head and tail plus minus 1. So here you assume plus minus 1. So again, the total error possibilities are 5, and the values of those errors are -4 to +4. And again the same question, that what is the most probable or most likely occurrence of combination, which errors? And again the answer is actually this 0. So what are the other possibilities are there? So if you just jot down all the possibilities, how many times it would look like this? Suppose it is for 10, not for 4, it is for 10, and it gives you a beautiful symmetric pattern, right? So these are the frequency, that how many times that particular possibility would occur, and this is the values, right? So it is for 10 is the bar chart done by Excel. And if you go on increasing the value, say 100 coins, then you will get even better looking beautiful curve, but symmetric. And if you do it 1000 times, so you are almost getting a continuous curve, but really they are not continuous. They are discrete, but the values are very close. So the y-axis gives you the probability, or you can say, or the frequency, or the number of times that occur. Now the question is that whatever the number n big is, you are getting a discontinuous or discrete curve. But can I have a mathematical formula, a function of say fx as a function of x, which would exactly reproduce this pattern? It is not that easy. Now it is easy because you all know, but it was done by all-time one of the greatest mathematician, Carl Friedrich Gauss, and after that name we call it Gaussian distribution. So the inorganic chemists who are here, particularly analytical chemists, and maybe some computer people or physics people are there in this seminar, so they know it very well, Gaussian distribution, and it is like this. So it's a function, you know, e to the power something, and that something square, so it is always positive, and a negative sign is there. So it is in both sides of x, it will fall down, and since square is there, so it is a symmetric. And at x equal to mu, it is 0, so e to the power 0 is 1, so that would give you the maximum at the middle, that means the average or mean. So you see, the Gaussian distribution is some distribution, we call it normal distribution sometimes. It is prevalent in almost all the subjects, including economics, biology, physics, chemistry, medicinal chemistry, everywhere, because it's a very powerful statistical distribution form. But that's why you have to understand as a chemist that what it really means, particularly what these two parameters, sigma and mu, what do they mean. So for that purpose, I will suggest you to go for Excel and just translate this function in Excel. If you can, then you can very easily change the parameter mu and sigma and see how the graph is changing, and then quite visibly and beautifully it would give you the sense that what really mu and sigma stand for. Actually, let me say you that one is associated with the mean value, that is this one. In this graph, it is mu equal to 0. You can put, if you put mu equal to 1, then the graph will shift towards right at +1. The average would be height, maximum would be +1. If you give mu equal to -1, then the graph would shift immediately to the left. So you can play with this pattern, you know, in the Excel. And what about sigma? Sigma is associated with the width, that how wide that distribution is. It may be a very narrow one, it may be a very broad one, and that is controlled by this sigma value. So you can play with changing the sigma and mu value and visualize the graph. In some other day, if I get the chance, I can illustrate it again. Today I have some problem, technical and time problem also. So let me just take a few more seconds. The future of computer and computation, and we know quantum computers is the future of our computers. And what about the computation? It is the artificial intelligence computation. So that's altogether very advanced something. If I get chance some other day, I can discuss these things, of course. This is a picture of the quantum computer, you know, the IBM 50 qubit quantum computer, and two beautiful pictures done by quantum computing, these two beautiful pictures, and including artificial intelligence. These are the two pictures given by quantum computing involving artificial intelligence. So a long way to go. These are in experimental stage only. A long way to go to have it in our market, in our research laboratory. So let us hope for the best for the future, for the best 2021, and hope you will have a very good, happy year 2021. So with this much, I would like to thank you. Thank you.